All right, welcome back. We are on, I think I've been calling it lesson 4.2, but it is not in your note packets that way. But lesson 4.2 on linear functions. So the very first lesson you were introduced to two variable equations. You have an x and you have a y, and we have an input and an output. Now what we're going to do is we're going to take it up a notch. You're going to have an equation, you're going to make a table, and then you're going to make a graph. So it says I can define, evaluate, and compare functions through points, tables, graphs, and story problems. So we are on page 5 of our note packets. Functions can be represented by an equation, and you've seen an equation, a table, you've had some experience with a table, or a graph, and that's going to kind of be the new thing today. A graph of a linear function is a straight line. Now, everything you're going to graph is going to make a straight line. If it doesn't make a straight line, it's a red flag that you did something wrong. I also want you to look at, notice it said it was linear functions. Well, look at the root word of linear. It says that it is a line. So all of these functions are going to make a line. Now, we're going to start in different spots and different places with this function. We're going to start with what you are used to first as an equation. We're going to make a table, and then we're going to make a graph. So you can see from equation, we're going to table, and then we're going to graph. So here's my equation. Y equals x plus 1. So it does have two variables. It has input and output. And the table this time, I introduced you to a 3-column table. A 3-column table. So a little bit different. I kind of like a 3-column table. But this would be my x or my input. The function you're actually going to write is here. Y equals x plus 1. So that's my actual function. And then my output is my y. So a 3-column table actually allows you to kind of do the math right inside here if you don't need a lot of work to do. Now, if you don't have numbers given, usually there's some go-to numbers, but usually for this part, I will give you some numbers, but if I don't give you numbers, you should always test a positive number, a negative number, and 0. But we're going to test some of my normal go-tos, which are -1, or excuse me, -2, -1, 0, 1, and 2. And so I'm going to leave off this y equals and just kind of concentrate on this part of the function, x plus 1. So where x is, the first time I'm going to put in -2. So I have -2 plus 1. And that's pretty easy. -2 plus 1 is -1. So my output is -1. Okay. Now, what that actually makes is a point for the graph. It makes a coordinate, it's called, or an ordered pair is another name for it. So this is x. Whoops, let me put that in black. This is x, and then you have y. So my x is -2. My y was -1. And that gives you a point on the graph to actually place. So it means when you do this that your x should be how far you go left or right, and your y should be how far you go up or down. Okay, so this means I go to -2, and then I go down to -1, and I place a dot. So taking that input and output, actually making a point, and then graphing the point. All right, let's do the next one. So I'm going to plug in -1 plus 1. -1 plus 1 is 0. So my point is actually -1, 0. So at -1, 0, go left to -1, and then at 0 right here, you place a dot. Okay. Next, you are going to be at, you're going to plug in a 0. So I'm going to plug in 0 plus 1. And 0 plus 1 is 1. So my next point is 0, 1. So I don't go anywhere left or right, and I go up to 1, and I place a dot. Are they starting to make a line? Because they should. All right, next, I'm going to plug in 1. So I have 1 plus 1. 1 plus 1 is 2. So my next point is 1, 2. So over 1, up to 2. And last but not least, I'm going to plug in 2. So it's going to be 2 plus 1. And 2 plus 1 is 3. So my actual point is 2, 3. Over to 2, up to 3. Now, it makes a line. They're all in a line. If it didn't, that's a red flag to you. Now, you're going to pick up a straight edge. Do not freehand these ever. You want to pick up a straight edge, so pick up a ruler, and you are going to line them up and connect the dots. So that's what I'm doing. I know you can't see my ruler, but I actually have a ruler here. I line them up, and I connect my dots. Notice I go through the entire graph, and I put end arrow marks. So that's what we have, ladies and gentlemen. We start with an equation or a function. We made a table. We got points from the table and graphed them. All right, so here we go. Next one. My input would be x. My function this time is y equals negative 2x plus 1. And my output would be y. So I'm going to give you some numbers to test out. You're going to test 2. You're going to test negative 1. You're going to test 3. You're going to test 0. And you're going to test 4. So they are kind of random. I should have put them in order and I didn't. And you're going to plug it in. So again, I'm going to just rely on this function part right here. And I'm going to plug it in. This one's a little more complicated, so you might have to do some math off to the side or on that scrap sheet of paper. Negative 2 times 2 plus 1. And some of you can do that in your head. So you really have negative 2 times 2 plus 1. Negative 2 times 2 is negative 4. And negative 4 plus 1 is negative 3. So my output is actually negative 3. So my point is 2, negative 3. So at 2, negative 3, I place it out. Okay. Next one. And remember, the first number goes left or right. Second number goes up or down. All right. So now I'm going to plug in negative 1. So negative 2 times negative 1 plus 1. So I have negative 2 times negative 1 plus 1. Negative 2 times negative 1 is 2. And 2 plus 1 is 3. So my new point is negative 1, 3. So at negative 1, 3, I place a dot. Hard to tell right now, but kind of eyeballing it, they look like they're in a line. So let's do my next one. I do 3 times 0 plus 1. This one I'm not going to write off to the side because I can do that one in my head. 3 times 0 is 0. 0 plus 1. Oh, wait. Whoopsie. I skipped over 1. Let me go back down to here. So this would actually be 3 times 0. Whoops, I went over 1. Sorry about that. 3 times 0 plus 1. So that's 0. 0 plus 1 is just 1. So my point would be actually 0, 1. So at 0, 1, I place a dot. And that looks like it is lining up. Let me see if I can, let's see. There. Okay, good. And let me go back up to do that one. Sorry about that. Oh, I erased a little bit more, but I think you can see it. 3 times 3 plus 1. And again, some of you are starting to be able to do these in your head, and that's fine. So you have 3 times 3 plus 1. 3 times 3 is 9. 9 plus 1 is 10. So my actual point here would be 3. Did I do that right? Oh, man. I'm really messing this up. Let's go back. Oh, goodness gracious. I think I messed this up. This one I messed up too, but actually it's not going to change my answer. This should actually be a -2 times 0. Wow, sorry. Were you guys hollering at me? So a -2 times 0 would be 0 plus 1, which would be 1. That doesn't mess it up. So this should be a -2. Whoops, jeez. -2 times 3. Let's rewind. Plus 1. So -2 times 3. So this should be -2 times 3, which is -6. -6 plus 1 is 5. So this should actually be 5. So my new point would be 3. And it should be -5. Wowza. Wowza, wowza. Mrs. Smith's losing it. -5. Wow. So this should be -5. And this should be -5. And then 3, -5. Oh yeah, that is right there. And you know how I knew it wasn't right? I started to look at the graph and went, wait a second, it's not going to make a line. I've done something wrong. So that's how I knew. And then next, and last but not least, and hopefully I can get this one right on the first try. Yeeks. So I have -2 times 4 plus 1, and -2 times 4 is -8. -8 plus 1 is -7. That's looking correct. Oh boy. So I have 4 times -7. So 4 times -7. Yep. And it's lining up. All right. So I'm going to pick up my straight edge. It did make a line. I know you can't see my straight edge, but I do have a ruler. I'm connecting my dots, and dun, da, da, da. I go all the way through the graph, and I put on an arrow mark showing that it keeps going. Keeps going. All right. Now, the next one. And then we're going to do one more maybe. The next one changes things up a little bit. Oh my goodness, what is this? I want to show you that. It is F parentheses X, which it's read F of X. That's how it's read. You would say F of X is how you would read it. And F of X is really called function notation. Now remember, this whole chapter is about functions. So that's how you would write a function, F of X. And that happens to be the most popular function, F of X. Just like X is probably the most popular variable. And really, all it boils down to is that it means Y. So this really means Y equals -2x plus 5. It does not change a thing, but I wanted to introduce that to you so that you could, if you saw it again, you wouldn't totally freak. Okay, so it just is fancy for Y. F of X is function notation. It's just fancy way to write a Y. So here's X, and here is, we could call it F of X, or we could just call it Y, but I wanted to show you that. All right, and this time I want you to test out 0, -1, and 2. So go ahead and pause the video, test those out, and plot them on your graph and get back with me. So here we go. I'm going to do mine. So I have, and notice I went back to a 2-column table, so I got to do my work off to the side. So -2 times 0 plus 5. So -2 times 0 is 0, and 0 plus 5 is 5. So that makes my point 0, 5. And that's what I'm going to plug in, 0, 5. Boom. Next one, I'm going to plug in -1, so -2 times -1 plus 5. -2 times -1 is 2, and 2 plus 5 is 7. So my next point is -1, 7. So -1, 7 all the way up here. And last but not least, I'm going to plug in 2. So you have -2 times 2 plus 5. So -2 times 2 is -4. -4 plus 5 is 1. Okay, so then my last point is 2, 1. Let's see, make sure it lines up and makes a line. 2, 1. It does. So I pick up my straight edge and I play connect the dots. Remember when you used to connect the dots when you were real little? When you were learning your numbers and you'd go from one thing to another and make it a pretty little shape? It's kind of what we're doing now, but our pretty little shape is a line. It's a line. All right. Last one. And I really throw you a curveball because I give you a fraction. Now, I want to talk about this fraction because it is going to be worth your while to look at the denominator. Notice again, I have f of x, which again does not change anything. That's no different than y equals 2/3 x minus 1. All right, so 2/3 x minus 1. So my input would be x, my output would be f of x, or let's just change it to y. Now, because the denominator is 3 and it's a fraction, I want you to look at the denominator, and the numbers we're going to test are going to work well with 3. So say, for instance, I have 3. I'm going to skip count or do multiples. 3, 6, 9, 12. And then that way, when I do the math, it will give me a nice fraction, or it'll give me a nice whole number. Say if my denominator was 4, I would skip count by 4s and test numbers like that. 4, 8, 12, 16. Halves aren't too bad, so if it's a 2, you could do 2, 4, 6. That would be fine too. But I'm going to test out numbers that work well with 3. So these right here. And so when I go to test, I'm going to test -6, -3, 0, 3, and 6. And that's going to help me not get fractional amounts. So I use that denominator here to get a whole number answer. So you've got your calculator there. Of course, you should know how to do some fractions. So you've got y equals 2/3, and then I'm going to times it by a -6, and then minus 1. So this is actually 2/3 times -6/1, and then minus 1. Now, if you remember from your fraction days, you could cross cancel. I can't cross cancel 2 and 1, but I could divide these both by 3. And 3 divided by 3 is 1. -6 divided by 3 is -2. And I have 2 times -2, which is -4/1, which is just -4. And -4 minus 1 is -5. So when I input -6, I get out -5. So my point is -6, -5, -6, -5, right down here, like, right there. Any place a dot. Okay. Now, I can also kind of show you a shortcut here, and we'll show you the shortcut on the next one. So it's 2/3 times -3 minus 1. So notice I really have 2/3 times -3/1 minus 1. Now, what I can do is I could just go from here, and I could do this a couple different ways. I guess if I left it like this, and say I didn't cross cancel like I did on the last one, maybe you do this, 2 times -3, which is -6 divided by 3 minus 1. Well, what's -6 divided by 3? That's -2. And -2 minus 1 is -3. So that would work out. That's one way to look at it. The other way is I kind of go like this, and I say 3 goes into -3 how many times? A -1. And then 2 times -1 is -2. And then I have minus 1. So that's another way to look at it. Okay, so now I have 2/3 times 0. I love when I have a 0 because that makes things easy. So 2/3 times 0, and then minus 1. So 2/3 times 0 is 0. 0 minus 1 is -1. So I plot in -1. And actually, I forgot to plot my last point, so I'm going to plot both of them this time. So I have a -3, -3. So a -3, -3. That goes here. And I have a 0, -1, and that goes here. Okay, so let's do the next ones. So I have 2/3 times 3, and then -1. So I do 3 goes into 3 one time. 2 times 1 is 2, and 2 minus 1 is 1. That's how I do it. So my output would be 1. So my point would actually be 3, 1. So 3, 1, 3, 1. It looks like it's making a line. Yay! And last but not least, 2/3 times 6, 6, and then -1. And that would be, you could put it over 1, and you could do 2 times 6, which is 12 divided by 3, -1. 12 divided by 3 is 4, and 4 minus 1 is 3. You could do it that way too. Whatever way works best for you. And so then my last point is 6, 3. So 6 and 3 right here. And indeed, I got me a line. Woohoo! So pick up your straight edge and connect. Make sure you go all the way through the graph and put end arrow marks. So with fractions, use your multiples to help you get numbers so you have whole numbers to graph. All right, good luck.